Welcome to our final video. This is video 6 of 6 covering exam section 4 on model deployment. This section tests whether you understand the 3 deployment approaches, when to use each one, and the specific Databricks tools that implement them. Let's finish on a strong note. We'll start by comparing the 3 deployment approaches. Then we will dive into implementation details for each of them. So what are the 3 deployment approaches, right? There are 3 ways to deploy a model for inference, and the exam expects you know all of them. Batch inference processes large data sets on a schedule, whether it is hourly, daily, or weekly. You are generating predictions for many records at once and storing the results for a later consumption. Real-time inference, also called online inference, uses REST API endpoints to generate predictions on demand. A client sends a request with input data and the endpoint returns a prediction in milliseconds. Streaming inference continuously processes incoming data streams, generating predictions as the new data arrives. So the choice depends on 3 factors: latency requirements, how fast do you need the predictions, data volume, how much data you have, and obviously, and importantly, the infrastructure cost. In practice, most production ML systems use a combination of all 3. You might use batch inference for daily risk scores, real-time serving for recommendation API, and streaming for fraud detection. The exam tests your ability to choose the right approach for a given scenario. Let me compare batch and real-time side by side, since these are the 2 most commonly tested. Batch inference processes millions of records efficiently. You schedule it through Databricks jobs. For distributed inference, you use pandas UDFs or MLflow Spark UDF to parallelize across the cluster. Results are stored in delta tables for downstream applications. Batch offers the highest throughput, but also the highest latency. Results are only fresh as your last batch run, actually. So the results might not be that fresh. On the other hand, real-time inference delivers millisecond latency through REST API endpoints. On Databricks, this is model serving. Endpoints auto-scale based on the traffic, so you don't need to manage the compute manually. They support A/B testing through traffic splitting, routing percentages of requests to different model versions. Real-time offers low throughput, but the lowest latency. When the exam describes a scenario needing instant predictions, like a web app recommender, the answer is real-time serving. And when it describes processing a large historical data set, the answer is always batch. So now let's get into the implementation details for each approach. The exam tests specific code patterns and methods for this. So let's start with batch inference. For batch inference, there are 2 patterns depending on your data scale. For small data that actually fits into your memory, load the model with MLflow.python.load model using the champion alias, load your dataset as a pandas data frame, and then call model.predict to generate predictions. It's simple and fast. For larger data that requires distributed processing, use MLflow.python Spark UDF. This wraps your MLflow model as a Spark user-defined function. You apply it to a Spark data frame using with column, adding a new predictions column. Each partition of your data is processed in parallel across the clusters. Write the results to a delta table for downstream consumption. This is the standard Databricks pattern: read from delta, predict, and write back to delta. The exam specifically mentions using pandas for batch inference and Spark UDF for scaling to Spark. You should know both the patterns. Deploying a model serving endpoint, let's talk about it. For real-time inference, you deploy a model serving endpoint. First, register your model in Unity catalog. You need a registered model to create an endpoint. Then create the endpoint through Databricks UI, the REST API, or the Python SDK. You specify the model name and the version or alias like champion and the compute size. The endpoint provides a REST API URL. You query it with a post request containing JSON input, and and it just returns your predictions. For custom pre-processing or post-processing logic, use PyFunk models. A PyFunk model lets you wrap arbitrary Python code around your model, like cleaning inputs, transforming outputs, calling multiple models in sequence. The exam specifically mentions deploying models to endpoints, and PyFunk is how you do it. Now let's talk about traffic splitting for A/B testing. One of the most practical features of model serving is traffic splitting. You configure your endpoint to route percentages of incoming traffic to different model versions. For example, you send 90% of requests to your champion model and 10% to a new challenger model. Both models serve real traffic, so you can compare their performance head to head under real conditions. As the challenger proves itself, you gradually shift more traffic towards it. If it performs worse, you shift back. This is actually configured in endpoint settings, either through the UI or API. You specify traffic weights for each model version. The exam actually asks about splitting the data between endpoints for real-time inference. The answer is traffic splitting for A/B testing. This enables safe, gradual rollout of your new models without risking the full cutover. Now let's talk about streaming inference with delta live tables. This is the trickiest deployment topic on the exam, and it's tested with a sample question as well. So please pay close attention. Delta live tables is a declarative framework for building reliable data pipelines. For streaming inference, you apply your ML model as a Spark UDF within a DLT pipeline. DLT handles auto-scaling, schema enforcement, error handling, and monitoring. All the things that you have built manually with plain structured streaming. Databricks recommends DLT over structured streaming for production pipelines. Now here's the critical exam distinction, right? The sample question describes a podcast platform that needs to process tens or thousands of events per second with dynamically resizing compute. The options include DLT with a Spark UDF, structured streaming with a Spark UDF, DLT calling a model serving endpoint, and structured streaming calling an endpoint. The correct answer is DLT with a Spark UDF. Why? Because DLT dynamically resizes compute based on your data volume, exactly what the scenario requires. And applying the model as UDF within the pipeline is faster and more efficient than making network calls to an external serving endpoint. The wrong answers are the ones involving model serving endpoint calls from within a streaming pipeline. Calling an external endpoint from a streaming UDF adds latency, network overhead, and a point of failure. Keep the model inside the pipeline. This is one of the most important distinctions for the exam. DLT plus Spark UDF for streaming inference, not endpoint calls. Let's lock in the deployment essentials. For batch, use Spark UDF for distributed inference and store results in data tables. For real-time, model serving endpoints provide REST APIs with auto-scaling and traffic splitting for A/B testing. Streaming, delta live tables with Spark UDFs and not the model serving endpoint calls. DLT actually handles auto-scaling for fluctuating data volumes. Custom PyFunk models enable you to add pre-processing and post-processing logic to the serving endpoints. These are the key distinctions that the exam tests in the deployment section. And that's it. You have completed the full course. Over these 7 videos, we have covered every section of the Databricks Certified ML Learning Associate exam, from MLOps and ML runtime through AutoML, feature store, and MLflow into data processing, model development, and finally the deployment. Let me leave you with some final advice. Go back through the exam outline and check off every objective. If anything feels fuzzy, rewatch that section. Practice in Databricks workspace if you can, and remember the key themes that run through the whole exam. Use feature engineering client and not the feature store client. Promote code versus promote models. Search runs for the best run. DLT with Spark UDF for streaming. And always exponentiate log transform predictions before computing metrics. You have put in the work. Now go and pass that exam. Good luck and congratulations on investing in your career. I'll see you on the other side. Thank you.